As promised in the introduction, I'm going to discuss two sampling distributions, and I would like to start with the first one, which is the sampling distribution of the mean. This type of distribution has two very interesting properties. First of all, the mean of the sampling distribution is equal to the mean of the sampled population. So, whenever you estimate some mean based on a sample, you can expect this mean to be equal to the mean from the sampled population. Another property is related to the standard deviation of the sampling distribution of the mean, which is calculated in the following way. So standard deviation, so sigma, of the sampled population is divided by the square root out of n, which is the number of observations or sample size. Sampling distribution of the mean has two interesting theorems. First of all, if a random sample of observations is selected from a population with normal distribution, the sampling distribution of the mean will be also a normal distribution. And the second theorem is the very famous central limit theorem. So if the sample size is more than 30 observations, the sampling distribution of the mean will be approximately a normal distribution, so with its mean being equal to the population mean and standard deviation defined as population standard deviation divided by the square root out of n. So in simple words, if you have more than 30 observations in your sample, the sampling distribution is nothing else but just normal distribution. And for this type of distribution, we can calculate the z-value, or z-score, which is defined as sample mean minus mean of the sampling distribution divided by standard deviation of the sampling distribution, which can also be written as sample mean minus population mean divided by population standard deviation and divided by the square root out of the number of observations. To see how this formula is used on some example, let's have a look at example number 4. So let's assume that there is a manufacturer of automobile batteries who claims that the distribution of the length of life of his best battery has a mean of 54 months and the standard deviation of 6 months. Suppose a consumer group decides to check the claim by purchasing a sample of 50 of the batteries and subjecting them to tests that estimate the battery's life. Assuming the manufacturer's claim is true, what is the probability that a consumer group sample has a mean life of 52 or fewer months? So from this example, we can get a number of pieces of information. First of all, the mean of the sampling distribution is equal to the population mean, and in this case it will be equal to 54 months. So it is equal to what an automobile batteries manufacturer claims to be true, that the true mean life of its battery is 54 months. We also know that the standard deviation that the manufacturer is claiming to be true for all its batteries, so for the whole population of its batteries, is 6 months. So sigma is equal to 6. And then some consumer decides to check if a manufacturer is lying or not, and he or she purchases 50 batteries. So the sample size is 50. And we would like to know whether the consumer group sample to those 50 batteries has a mean life of 52 or fewer months. So we assume that the sample mean is 52 months. And to answer that question, whether consumer group sample has mean life of 52 or fewer months, first of all, we need to calculate the z-score. So we substitute everything into the formula. So the sample mean is 52, so the value that we would like to check whether it's true or not. The population mean, so the one that is claimed by the manufacturer, is 54. We divide it by 6, which is standard deviation claimed by the manufacturer, and divided by the square root out of the sample size, which is 50 batteries. And we get that z-score is equal to negative 2.35. So the probability that we are interested in is that the mean life of a battery, so the mean value is lower than 52 or equal to 52, which is equivalent to estimating the probability that z-score is lower than negative 2.35. As always, we can make a graph for better understanding of the situation. So 54, this is the so-called claimed to be true population mean, 54, so we put it in the middle of the distribution. And we are interested in the part of the distribution to the left of 52, so everything that is lower than 52. To get this value, we take 0.5, so half of the distribution, 50% of the distribution, so everything from the left side, and we subtract area A. So the probability that z-score lies between 0 and negative 2.35, which if we open the z-score table, we will see is equal to 0.4906, and we get the probability of 0.0094. So the probability that the consumer group sample has a mean life of 52 or fewer months is 0.94%.